Hi, this is part 2 of Lecture 9. So I will continue with explaining about STP operation. So before I start with the explanation of the STP operation, I will introduce some of the terminologies needed for you to understand how STP works, or how STAO, which is the spanning tree algorithm, works in a network. So first we need to understand a root bridge. Okay, so what is root bridge? So here we use the terms bridge, but actually bridge refers to switch. So root bridge or root switch is the switch when you have more than two or more switches. So root bridge is the switch that made all forwarding decision in STP. So the root bridge need to be elected when you run the ST spanning tree algorithm. So the algorithm will elect, okay, will choose the best root bridge. So what is the criteria of choosing the root bridge? So basically they will compare the bridge ID. Okay, they will compare the bridge ID. So bridge ID consists of two parts, which is priority and the MAC address. So basically, first it will look at the priority. If the priority of the switch is the lowest among all switches, so basically that particular switch will be elected as root bridge. However, if all of the switches has the same priority, so basically they will elect the root bridge based on the second criteria, which is the MAC address. So they will choose the switch with the lowest MAC address. Right? So in this diagram, you could see that we have three switches, which is S1, S2, and S3. So basically to understand the root bridge, so look at the priority. So you can see that switch 1 has the lowest priority, which is 24577. The other switches has the priority of 32769. Hence the reason why switch 1 is elected as the root bridge. And then the rest of the switches will become the non-root bridge. Okay, so this is the switches that receive update from root bridge, and update is STP database. So basically S2 in this diagram, in this example, S2 and S3 it will become the non-root bridge. And then we have another terminologies. Okay, so I have explained about root bridge and non-root bridge. Now let's look about the root port. So what is the root port? So all switch has the port that is connected to the link to the switch. So the port on the non-root bridge that is directly connected with root bridge or has the shortest path to the root bridge will become the root port. So in this example, the non-root bridge is S2 and S3. So on S2 for example, F01 is the port that is directly connected to the root bridge. And on S3, F01 is also the port that is directly connected to root bridge. So that it will become the root port. Now we have another two ports, which is designated port and block port or alternate port. So basically this is what we are going to determine today using the STP algorithm. We want to determine which port will be blocked using the spanning tree protocol. I will explain how later in the subsequent slides of how STP will elect or select the block port in the network. But let us understand what is designated port and non-designated port or the block port. So designated port is the port on the segment that has the internal root path cost to the root bridge. So basically, you have to calculate the path cost to the root bridge. So basically, the port that has the lowest cost to the root bridge will become the designated port. But I will explain later how the designated port is elected. But you have to understand that we have another port which is block port, where the port that has higher port cost than the designated port earlier on that I have explained will be disabled to remove the layer 2 loop. Nonetheless, I will explain again later on how the election of the root bridge, non-root bridge, the root ports, designated port, and also alternate ports happened using the spanning tree protocol. So now, what is the step to create a loop-free topology is by electing alternate port or the block ports. So we need to, the STP will determine which port to be blocked so that the frame forwarding will not be in a loop. So there are 5 steps that we need to do using the STA. What is STA? STA, the spanning tree algorithm. So there's 5 steps actually. Actually, there's 4 steps. You need to elect the root bridge, but I determine the root path cost within the steps, because in order for you to elect the root ports, to elect the designated port, to elect the block port, we need to first determine the root path cost, right? So now the first step one is for us to elect the root bridge. But before we understand how can we elect the root bridge, so we need to understand what is the criteria to elect the root bridge. I have explained earlier on that there are 2 criteria, which is the priority and also the MAC address. So basically, what is bridge priority or switch priority? So all of the switches, Cisco switches by default will be given a priority value. So the value is 32768. Okay, so that's the priority value by default. However, as a network admin, you can manually change the bridge priority if you would like or you want certain switches to become the root bridge because of many reasons. Right? So basically, what you can do is you can change the bridge priority to become lower priority than other switches. Like for example, you can set certain switch with the priority value 2000, 20,000 or 2,000, for example, or 1. And the number could range from 0 until 61440, and the number need to be in increments of 4096. Okay, so when you have 2 switches, switch 1 and switch 2, and switch 2 has lower priority than switch 1, so basically switch 2 will be selected as the root bridge. However, if you do not wish to change the priority, you just want to take the default value for the switch, so the switch will select the root bridge according to another criteria, which is the MAC address. So when you have 2 switches, so the switch will select the a switch with, STP algorithm will select the switch with lower MAC address. Like for example, if switch 1 MAC address is A0, for example, A0, and switch 2 the MAC address is A1. So basically, switch 1 will be elected as the root bridge, okay, because A0 is lower than, has the lower value than A1. So now we have another criteria here, which is a standard system ID. So by default, when you not configuring anything, the default VLAN for all of the switches is VLAN 1. So basically, here you can see that the value, the bridge value, priority value is actually the bridge priority plus the standard system ID. So hence the reason why you see in the subsequent the value in the slide, the priority value in the slide, the value is 32769, because by default the VLAN that is assigned to the switch is VLAN 1. So 32768 plus 1 is 32779. So that's why you see here the priority is 32769 instead of 32768. The default priority value is 32768, but because we added VLAN 1 ID, so the value now becomes 32769. So now let us go to the first step of the STP operation, which is electing the root bridge. So this spanning tree protocol algorithm will elect the root bridge by referring to the lowest BID. So at first, all switches will declare themselves as the root bridge with their own BID. Eventually, when they already exchange the information using the bridge, the BPDU, so a bridge protocol data unit. So basically, they will look and elect the switch with the lowest BID. So you see here we have 3 switches in the example. So switch 1 has the lowest BID, which is priority 24577. Can see here. So now S1 is elected as the root bridge, even though the MAC address of S1 is the highest among all, right? But because S1 has the lowest priority, so basically S1 is elected as the root bridge. So this, you can see that if you do not change the default value, of the bridge priority, so you the S2, yes, S2 should be elected, but because now we have changed the priority of the switch from 32769 to 24577, so hence the reason why S1 is elected as the root bridge. The second step now let us look at the impact of the default BID first. So because the default BID is 32768, okay, this is what I have explained before. If you have same default BID for all, so basically they will look for the second criteria, which is the lowest MAC address to elect the root bridge. So now in the figure you can see that all switches alright. Okay, I think I already explained all, right? If you read carefully, I already explained early on the VLAN ID. I mean, the priority is added with 1 because they will add the VLAN ID to the priorities. So yeah, so I already explained how S1 is selected as root bridge. Now, let us see the second steps. Okay, the second steps is the STA will determine the root path cost. So when we have elect the root bridge, so STA, the spanning tree algorithm, will start determine the best path to go to the root bridge from all destination in the broadcast domain. So basically, you have to understand that every time a switch receives the BPDU, so it will add the ingress port cost of the segment to determine its internal root path cost. So now, by default, Cisco use the original STP protocol. Okay, so the original STP protocol is defined by the IEEE 802.1d standard. Okay, so that is the original. But nowadays, okay, if you do not configure anything, so STP, the original STP is enabled by default on the Cisco switch. But you could also enable another variant, another version, okay, the newer version of STP, which we call as RSTP on Cisco switches. So you have to understand that the cost value between the STP, which is the original version of the STP, and RSTP cost is different. Okay, so the RSTP and STP here differs according to the link speed. So kalau if you use UTP cable, okay, UTP cable, so the cost of the port, like UTP cable the link speed FA0. If you use FA01, for example, fast Ethernet, FE, so basically the port cost is 19. But if you use, like for example here, gigabit Ethernet, GE, so the port cost is 4. So if the link speed goes higher, so the cost of the STP will be lesser. Okay, so basically here, for the RSTP, the cost differs where if the link speed is fast Ethernet, the port is the fast Ethernet port, so the cost is 200,000. If it's gigabit Ethernet, so the cost is 20,000, and if it's 10 gigabit per second link speed, so the cost is 2,000. Right? So the cost depends on what is the STP version that you have or that you enabled on the Cisco switches. So the table just give an idea of the link speed, but now what we really need to do is we need to actually calculate the path cost. So say for example here, because I already says that the cost is calculated from the end device of the broadcast domain. So we assume that the packet coming from PC1, PC2, PC3. So if the packet is coming from this segment, so the frame can be forwarded to another segment, which is PC4, using two paths, which is path 1, this is path 1, and path 2. So we have two paths here. So what you have to do is, it's not like what you have to do. What the spanning tree algorithm does is, it will calculate the cost, the path cost to the root bridge. So for example, for path 1, you see here, the port is F. So F is fast Ethernet. F01, so it's fast Ethernet. So we know that for STP, the original STP, the fast Ethernet cost is 19. Yeah? So to go from S2 to S1, so we have one fast Ethernet link. So basically the path cost is 19. But if we use path 2, where the path need to go through, the frame will be forwarded from S2 to S3 and S3 to S1. So the path cost doubles, which is 38. Okay, so because of that, we know that path 1 is the preferred path because it is the shortest path to go to the root bridge. Okay, so this is what you need to do, which is you need to determine the cost, the path cost. Next, once you already determine the path cost, so the next step is we will elect the root port. So after the root bridge has been determined by the spanning tree algorithm, so we need to select the root port. So the root port, okay, you need to remember, root port is only elected on non-root bridge. Okay, so root port is elected in non-root bridge. Okay, so we cannot elect a root port on a root bridge. It's only for non-root bridge. So What is the non-root bridge in the diagram? It is S2 and S3. So on S2 and S3, you need to identify the root port where the port is the closest to the root bridge in terms of overall cost to the root bridge. So you see here, like for example, S2. So S2, we have two ports, yeah, F01 and F02 that is connected, that will lead to root bridge. So which one that we want to use as root port? Is it F01 or F02? So we need to know between F01 and F02 which port is the closest to the root bridge in terms of the cost. So we know that for to go to from F01 to root bridge, the cost is 19. From F02 to root bridge, the cost is 38, right? So basically, definitely F01 will be selected on as the root port for switch 2. Okay, the same goes for S3. So on S3, we have two ports, F01 and F02. So of course, F01 is the closest port to the root bridge. So that's why, that's the reason why F01 is selected as root port on S3. Okay, now the fourth step, number 4, is this one is step number 4. Okay, so we elect designated port. So what is designated port? Okay, there is few condition. There is a few condition when we want to elect the designated port. First of all, for root bridge, all of the connected port will be the designated port, right? So that's the first thing. On root bridge, okay, on root bridge, so you see here the root bridge. So all of the connected port, it will become designated port. Okay. Now, second, okay, second criteria of electing a designated port, all ports attached to end device are designated ports. So for example, on S2, port number F011, F018, F06 is connected to PCs, right, which is the end device. So all of these port will become designated port. All of this become designated port. Alright. Now, third, okay, third, if one of a segment is a root port, the other end is a designated port. So for example, for this segment, okay, segment A, and then we have this segment, segment B, and then we have this segment, segment C. So looking at this, for the segment that has a root port is segment A and segment B only. So because on segment A, because F01 has become the root port, so F02 on S1 will become the designated port. The same goes to segment B, because F01 on switch 2 has become the root port, so F01 on switch 1 will become the designated port. But I think it's given because the first criteria that I said earlier on, all ports on the root bridge are designated port. So in this example, we already know that on switch 1, F01 and F02 is designated port. Okay. So now we are left with another segment here, okay, which is segment C. Okay, we on the segment C there is no root port, so basically that we need to elect one designated port. Okay, one designated port. So the segment C, okay, is the only segment between between the switches here that has neither root port or root bridge. So in this case, the port on the switch with the least qualified, okay, I just read this segment, this statement. So the port on the switch with the least cost path to the root bridge is the designated port for the segment. So for example, in this figure, both S2 and S3 have the same path cost to the root bridge. Okay, so maksud dia S3 you want to go to S1 is 19, S2 you want to go to S1 is also 19. So they have the same cost path. Okay, so basically the spanning tree algorithm will use the bridge ID as tiebreaker. So if you go back to the earlier slide, I cannot go back to the earlier slides in this video. So basically now S2 has lower MAC address than S3. Okay, S2 has lower MAC address than S3. So basically therefore F02 here, so F02 on port S2 will be chosen as the designated port. Okay, so that is something that you remember, because first it will look at the cost. Okay, the least cost. So you see S3 to go to S1 the cost is 19, S2 to go to S1 the cost is also 19. So they have the same cost. So if it's a tie, the path cost is the tie. So they will choose, the ST algorithm will choose the switch with lowest bridge ID. So in this case, if you go back to the previous diagram, you will see that switch 2 has the lowest MAC address. Okay, then S3, so that's why F02 is elected as designated port. Now, to elect the alternate port. So now, on the segment C again, here you see that there's only one port that is not elected at all. So basically, this port, which is F02, okay, will be elected as block port, because it's not a root port, it's not a designated port, that will become an alternate port. So alternate port are always in the discarding or blocking state. What it means by that, it means that they will receive the frame, but whenever they receive a frame, they will receive it, but they will not forward it. What happens is they will just discard the frame. Okay, so all other interswitch port like this will be in a forwarding state. So this is the loop prevention part of the spanning tree protocol. So I will stop now and I will continue in the next video.